we're convinced that technology creates the opportunity to unlock value in the African continent. We're doing that at Syama. We're taking Mako forward very successfully, and we're looking for new opportunities. And I hope you enjoy both the presentation that we give today, as well as following our progress in what is going to be a very important and pivotal year for Resolute. We raised almost 200 million Australian dollars in equity at the start of this year. We've repaired the balance sheet. Both of our operating assets at Syama and Mako are cash flow positive, and we believe we're at an inflection point as we move forward in our strategy of becoming a multi-mine, low-cost African gold producer. A key element of the transition of Syama is the automation project that we're going to hear about from Mohammed. But as equally important in delivering our ambitions for that mine to produce 300,000 ounces of gold at $750 an ounce is our work on our power generation. And it's obviously a key topic across the industry and very topical here in South Africa. Since inception, the Syama gold mine has been powered by diesel power station. It's a number of distinct units. It means that we're very reliant on diesel delivery, and the current power cost at Syama, depending on oil prices, is in the range of 25 cents per kilowatt hour. We've announced, along with our partners at Greco, the construction of the world's largest mine site-based solar hybrid power station. And before we talk about anything else at Syama, I wanted to play the video that's recently launched by Resolute and Greco that runs through some of the guidelines of what is going to be a key driver of future cost savings at Syama. This has very high-tech elements across a number of factors. The base power load is a heavy fuel oil power station, very efficient, and it's augmented by a 20 megawatt solar array and a 10 megawatt battery, which allows us to reduce our spinning reserve, increase our environmental positive outcomes, and most importantly, provide 15-cent kilowatt power. So a fundamental saving. We've started construction on that first stage of the thermal element of that mine. It'll be commissioned later this year at Syama. Part of the solar array program is actually aligned with our tailing storage management. Syama's been a mine for 30 years. And during the course of this year and next year, we'll be capping the existing tailings dam and covering that with the solar array immediately alongside the mine. So very positive environmental outcomes and very positive economic outcomes. And it demonstrates the partnership approach we think is absolutely essential to operating successful gold mines in Africa. We're a partner with our governments, we're a partner with our local communities, and we're increasingly bringing in best-of-breed, world-class partners to operate our mines alongside us. We're very confident that Greco are the leader in mine site-based power solutions, and we're looking forward to implementing that power station. The other key element of interest at Syama is our automated underground mine. Obviously, that's a partnership with Sandvik. This is a massive mine. We stopped open pit mining here in 2015. It was originally discovered by BHP. It was operated by Randgold, as I like to say. What would those two guys know about mining that we can't teach them? We've been pouring gold there since 2009, and as you can see in this picture, we've got a very large reserve base underneath us, and what you can see there is the sub-level cave that we're in the early stages of. We've constructed more than 25 kilometres of decline and tunnel. We're now at the early stages of drawing that cave. Geotechnically, it's working excellently. And we've commissioned a fully autonomous mine, autonomous drilling, autonomous loading, and autonomous haulage as a key feature of how we're going to operate the mine going forward.
We've made a partnership with Sandvik to create a sophisticated, efficient, and safe mine. And we've been using equipment that Sandvik have been deploying for the past 2 decades. The difference with Syama is, for the first time, a miner had the chance to purposely build or design a mine from the beginning for automation. All the equipment that we use at Syama are deployed elsewhere on autonomous mode. The difference is we have designed and we've accommodated automation from the start. We can see from the five past years, a lot of autonomous employment or deployment in underground mining. Apart from few underground mines like North Park in Australia or Kibali in the DRC with Randgold, now Barrick, or Finch Mine in South Africa, all these systems have consisted of a single LHD or multiple LHD used in sublevel cave or open stopes, or in the case of Kibali DRC, multiple loaders feeding a crusher. When it comes to autonomous trucking, apart from the large loop in Finch, there is very few underground mines, or certainly none that has automated the process of moving from a laser-guided system from underground to a GPS-guided system on surface. So Resolute Mining in West Africa, Kibali, is about to change that by designing a mine that is purposely built from start to accommodate the following: autonomous drilling, autonomous loading, autonomous tipping onto trucks, and autonomous loading all the way from underground to surface. So let me show you how that looks like. This is the key function for us. We all talk about automation, autonomous operation. For us, the key is the drilling part of it. By doing autonomous drilling, not only do we allow or do we manage to control our ore blanket, we manage to reduce our dilution also. Autonomous drilling is a key for us to really achieve the process of sublevel caving. For those familiar with sublevel caving, the first thing to do is your brow control. And autonomous drilling allows us to minimize the interaction of people on our brows. So brow control is very key for us. And with autonomous drilling, we've seen a lot of benefit. Some of the benefit we've seen in autonomous drilling is, first, improved productivity and accuracy. We're drilling more accurately, and these are real results from our Syama mine currently. We've got over 20% productivity benefit. We've got over 10% accuracy benefit in terms of autonomous drilling. So that's the first thing we've implemented when it came to Syama automation. As you can see in this short video, this is one of our operators from a control room environment. He's got 3 drill rigs in front of him, and we are the first actually in the industry to have implemented remote drilling and autonomous drilling away from underground. So what we do is set up a drill rig in front of our cave. The machine is set up to drill the whole fan autonomously. So the operator is there to monitor the system. He's not there to really worry about how am I going to drill this one hole of the fan, but the whole purpose for him is to sit there, monitor the drilling design, and make sure that the right area is being drilled. So we do the design separately, send that across to the computers. From there, you can just load the right ring you want to drill and drill from there. The next stage after the drilling process is the loading. We do autonomous loading for our drill point. That's a quick demo of how the autonomous loading happens. So one important thing that we've implemented as well at Syama is we partnered again with another great industry developer, which is Orica. We made a partnership with Orica to develop or to implement WebGen blasting. So after the drilling process, we go to wireless blasting. So we put wireless nets into our rings. We can pre-charge our rings. We pre-charge sometimes 5 to 10 rings. So as the loader loads one single drill point, as soon as it's finished, we can remotely fire the next ring to go. So the loaders keep loading the drill point autonomously, and they got 2 options. They can take the material either to our ore passes. We've got a chain of ore pass system in sublevel cave, and that's a loader tipping into one of our ore pass systems. And then we also have autonomous dumping onto a truck. We developed a split loading system, which we designed to accommodate automation, that a loader can autonomously tip onto a truck. So the loaded truck makes its way from underground all the way to surface. And in the process, two trucks can come across in the same decline and pass one another. So we've done that design. That's what you can see in these graphics over here. The trucks coming down and the trucks coming up from surface pass one another on our passing bays, which we designed for as well. From there, you can see the loaded truck coming out of underground. And this is an actual video of our Syama underground mine. We've got our trucks coming out of underground through laser-guided system. They transition to a GPS-guided system on surface. We are the world first to do that. And the trucks head all the way to the ROM pad, tip the material, and go back down again. So the loading and tracking of the system has been designed such that it's a continuous process. We all know automation is all about repetition. It's all about really getting productivity and making sure there is no delays. Apart from plant maintenance, which we control also, the whole system runs autonomously. Talking about the benefit of automation, we all know there's various benefits of it. We see benefit in terms of productivity. We see benefit in terms of efficiency. We see benefit in terms of the people side of it. We see benefit in terms of safety as well. So we believe that digitalization and automation is the way forward for developed countries or for mining industries in areas like Mali to step up and catch up with the rest of the world. We believe with automation that they can use the safety aspect of it. They can use the ease of training of automation, use automation as a training tool. We've got a control room environment, which is fully on surface. And what we use in that training control room environment is to train our operators. So it allows us to give the tool to the operators to control the automation system. And not only do we have ease of training, in Mali, if we had to start such a mine, a sub-level cave, from start without automation, the lack of qualified operators would have had us recruit expensive expats from elsewhere in the world. And the training process, we know in underground, it takes time. It takes a long process to train operators. It was going to take us about 2 to 3 years to get our operators to be really fluent or conversant with the system. So the main thing for us, as we keep saying to people, a lot of people deploy automation to replace jobs. We believe it's an opportunity for Africa, it's an opportunity for Mali to actually create jobs. It's an opportunity for us to have nationals on a chase controlling this equipment without going through lengthy training processes. We believe that the cost benefit of the likes of North Parkes, Kibali, or Finch Mine in terms of the productivity benefit, the 20 to 30% benefit they see is actually accurate. But where does this safety or this benefit come from? You can see a graphic of a conventional mine, and you see a split of productivity between day shift and night shift. In the conventional mine, we all see that there's big differences between productivity on day shift and night shift simply because of interaction, simply because of various meetings on day shift. So most of the time, the productivity on day shift is relatively lower than that of night shift. So the first step to improve that is to digitalize the mine. So we've got a system called OptiMine for that. By putting digitalization in place, the first thing you do is to improve the less productive hours you got in the mine. So you still don't get benefit over shift changes. You still don't get benefit during blasting time. But the next step you do after digitalization is to do automation. So with automation, not only do we get benefit in terms of starting the shift, in terms of increasing the less productive hours, you got also the benefit of automating within the shift changes. Operators can remotely start up machines and make them run autonomously within shift changes. And one important thing is we all know about underground mining. We blast every day. So doing blasting as well, you continue running your autonomous fleet. Automation has allowed us not only to remove our workers from the unsafe environment, but it has allowed us to also use various genders. We've got a number of ladies sitting on our chairs controlling these heavy fleet equipment. And in an environment like Mali in West Africa, it wouldn't be possible to put underground ladies in underground to operate such heavy equipment. So automation has been the tool for us to empower ladies on our operations. Other benefits of automation, most conventional ones that people know about, is the productivity, the efficiency, the continuity of operation as well. And we believe these are all part of normal automation, but the main focus for us is really to take the opportunity of automation, to take automation as a tool to train our locals, to empower our people as well. So automation is the next thing we want to engage with government institutions to take advantage of the shift of technology, to make sure that we shift away from the low-skilled jobs into high-skilled jobs and take opportunity of creating better opportunities for Africans, better opportunities for people that can be used anywhere else in the world.